Imagine a fire that burns hot and fast, consuming everything in its path. Now imagine that fire appearing to die out, leaving behind smoldering ash and the smell of smoke. But beneath the surface, something sinister lingers. The fire isn't truly gone, it's just sleeping, waiting for the right moment to return. This is the terrifying reality of zombie fires. Zombie fires are a hidden threat lurking beneath the surface, ready to reignite when conditions are favorable. As our planet warms and wildfires become more common, understanding zombie fires is more critical than ever. Zombie fires, also known as overwintering fires, burn deep in the ground, often smoldering for months, only to re-emerge the following spring or even a year later. Unlike typical wildfires that burn on the surface, zombie fires consume the organic layer of soil, rich in peat and decomposed plant matter. This layer, known as duff, acts as fuel, allowing the fire to smolder slowly underground, hidden from view. This slow, smoldering combustion produces smoke and releases greenhouse gases, but is often invisible on the surface. They can reignite unexpectedly, catching communities off guard and overwhelming firefighting resources. Their slow, smoldering nature makes them difficult to extinguish, requiring specialized equipment and techniques. Several key ingredients contribute to the creation of a zombie fire. A thick layer of organic soil, or duff, acts as the fuel source, allowing the fire to smolder underground for extended periods. Dry conditions are crucial, with drought-stricken forests providing the perfect environment. A prolonged period of warm weather helps maintain the smoldering embers. When a wildfire sweeps through, it ignites this fuel, and the flames race across the surface. However, beneath the surface, the fire finds its way into the thick layer of duff. This smoldering can continue for months, even under a blanket of snow, waiting for the right conditions to re-emerge. Zombie fires sustain themselves by consuming the organic matter in the soil. This slow, smoldering combustion releases heat, drying out the surrounding soil and creating ideal conditions for the fire to spread further underground. This subterranean network of smoldering embers can extend over vast areas, making them incredibly difficult to detect and extinguish. As temperatures rise and the weather becomes drier, the smoldering embers can ignite the dry vegetation above, leading to a resurgence of flames. This resurgence can occur weeks, months, or even a year after the initial fire, catching communities off guard. These fires highlight the complex challenges of wildfire management in a changing climate. One of the most well-documented cases of zombie fires occurred in Alaska in 2008. A lightning-sparked wildfire in the Yukon Flats seemed to be extinguished by the fall, but it continued to smolder underground throughout the winter. In the spring, as temperatures rose, the fire re-emerged, eventually scorching over 370,000 acres of boreal forest. In 2019, the Canadian Arctic experienced an unprecedented wildfire season, with zombie fires playing a significant role. Scientists believe that smoldering fires from the previous year reignited in the spring, fueled by record-breaking temperatures and dry conditions. These fires released an estimated 2.5 million tons of carbon into the atmosphere, highlighting the global impact of these seemingly localized events. In 2020, scientists in California discovered evidence of zombie fires smoldering in the aftermath of the state's devastating wildfire season. Zombie fires have a long-lasting impact on the environment. By consuming the organic matter in the soil, they deplete essential nutrients, making it difficult for vegetation to regrow. This can lead to soil erosion, increased water runoff, and a decline in biodiversity. The smoldering combustion releases greenhouse gases into the atmosphere, contributing to climate change. The slow burn of these fires also has implications for air quality, releasing harmful pollutants that can travel long distances and impact human health. Understanding the long-term consequences of these fires is crucial for developing effective mitigation and adaptation strategies. Preventing zombie fires requires a multi-pronged approach. Early detection is crucial, using infrared technology and satellite imagery to identify hotspots. Once detected, these areas can be targeted for extinguishing efforts before they have a chance to reignite. Public awareness and education are also paramount. Educating communities about the risks of zombie fires and the importance of reporting any signs of smoke or smoldering can aid in early detection and response. Implementing fire-wise practices such as clearing vegetation around homes and creating defensible spaces can help reduce the risk of wildfires and subsequent zombie fires. Reducing greenhouse gas emissions through a transition to renewable energy sources and sustainable land management practices is crucial for mitigating the long-term risks posed by these persistent infernos.